We're going to take a look in this video how to solve absolute value inequalities. The problem we have here is to solve and graph on a number line the following. The absolute value of 7x is greater than or equal to 21. So what we want to do is solve for x, and what we also want to do is use a number line to help us figure that out, or at least to visualize what the solution is. So we're going to sort of approach this the same way we approached the equality, solving for absolute value equalities. Okay, we're going to branch off in two directions. We know that 7x is going to be greater than or equal to 21. But we have to think about the negative side of it, meaning what's inside that absolute value can be a negative number. It can be negative 21, or it can be a number that has, is a larger negative number. It can be larger than negative 21. So what we'll say is we'll branch off and we'll say that 7x can be, and this is what we have to do, is change the sign. It can be less than or equal to negative 21. That means the numbers are going to be becoming more and more large in the negative direction. So when we solve for this, let's solve the positive side first. We're going to divide both sides by 7, and we'll get x is greater than or equal to 3. So on the number line, what that represents is number 3, and it's going to be greater than or equal to 3. So anything greater than or equal to 3 is going to be part of our solution. Okay? Meaning, well, let's try a number like 4, 5, 6, 7. Let's try that. Let's take the absolute value of 7 times 7 is greater than or equal to 21. Is this true? That's what we want to know. Well, it's just the absolute value of 49 is greater than or equal to 21, which is 49 is greater than or equal to 21. So that works. 7 is a solution, and in fact, any number in between is also a solution. Anything greater than or equal to 3. So let's look at the opposite, the part of the solution that is less than or equal to negative 21. We're going to divide both sides by 7, and we'll get x is less than or equal to negative 3. So this is the number, let's see, it's negative 3 down here. It says it's less than or equal to. That means we draw a solid dot indicating that's equal to negative 3, and the solution is anything less than or equal to negative 3. So that red line represents our solution. So let's just try a number. Maybe we try, I don't know, negative 11. Let's put that in our inequality right here and see if it works. 7 times negative 11, we're going to take the absolute value of that, is greater than or equal to 21. We go back to the original equation to check. So this is going to be negative 77. We'll take the absolute value of that, and that'll be greater than or equal to 21. We don't know. We're checking. Absolute value of negative 77 is just 77, and that is greater than or equal to 21. So that checks. So this one checks pretty good. So let's try a number that might be in between negative 3 and 3. Let's maybe try 1. Let's see if that will work. All right, so we're going to plug in 7 times 1. We'll take the absolute value of that. Is that greater than or equal to 21? Well, no, it isn't, right? Because 7 times 1 is just 7, and this is a false statement. This doesn't work. So we know that the solution does not occur in between negative 3 and 3. So in summary, kind of what we do with this problem is we're going to branch off in two directions. We're going to think of 7x as greater, that we're going to Think if 7x is greater than or equal to 21, that's what's inside that absolute value sign, okay? Or 7x could be, and we have to flip the sign, less than or equal to, and put a negative sign in front of that 21 to solve it. And that way we get two solutions. We get x is greater than or equal to 3, or x is less than or equal to negative 3. Let's try this next problem. Solve and graph on a number line. X plus 2, the absolute value of x plus 2 is greater than or equal to 7. We're going to branch it off and look at the two possibilities, or when x plus 2 is positive 7, or greater than or equal to positive 7, or x plus 2 is less than or equal to negative 7. So let's write them out. See if you can do the problem yourself and get what I get. So I'm going to look at x plus 2, and I'm going to write it in red just to make sure you realize what we're doing here. It's going to be less than or equal to negative 7. Not only do we flip the sign of the inequality, but we take the negative of what's on the right side of the equation. All right, let's go. Subtract 2 from both sides. We get x is greater than or equal to 5. And on the other side, we're going to subtract 2 from both sides, and we get x is less than or equal to negative 9. So on a number line, this looks something like this. Here's 0, here's 1, 2, 3, 4, 5. X is going to be greater than or equal to 5, or x is less than 2, 3, 4, 5, 6, 7, 8, 9, or equal to negative 9. And so that's the solution for the problem. If you're not convinced, you could plug in one of these numbers. For instance, let's plug in negative 2. X plus minus 2. Oops, that's not right. We'd say minus 2 is x, plus 2 is greater than or equal to 7. I'm just checking to see if this number is a solution. Well, minus 2 plus 2 is 0, and that is not greater than or equal to 7. So that doesn't work. Now you could plug in various other numbers, perhaps negative 11 and positive 7 into here to see if those situations work for this, and they will. But anyway, I hope you enjoyed this, and I hope this helps you solve the next few problems.